Maybe.
Hello, I'm Jasmine Melasaga, and I'm going to teach you about some theorems on right triangles. The first theorem that we're going to talk about is the Pythagorean theorem, which was named after the Greek mathematician named Pythagoras, who was credited for its discovery and its proof. Well, the Pythagorean theorem states that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. In formula, a squared plus b squared is equals to c squared. The proof is as follows. Let ACB be a right angled triangle with right angle CAB. On each of the sides BC, AB, and CA, squares are drawn. For side BC, the square drawn is square B, C, E, and D. For side AB, the squares drawn are A, B, F, and G. And for side AC, the square drawn is A, C, I, and H. The construction of squares requires the immediately preceding theorems in Euclid and depends upon the parallel postulate. From A, draw a line parallel to BD and CE. It will perpendicularly intersect BC and DE at K and L respectively. Now we must join C and F and A and D. It is for the reason to form the triangles BCF and BDA. Angles CAB and BAG are both right angles. Therefore, C, A, and G are collinear. Similarly for B, A, and H. Now, let us proceed to the next theorem, which is the Pythagorean theorem converse. It states that if the square of one side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. Did you guys know that the ancient Egyptians used to form right triangles by taking a rope with 12 equally spaced knots? They would form a right triangle with a length of 3, 4, and 5 knots. And we know that 3 squared plus 4 squared is equals to 5 squared. So does this prove that the triangle they formed was a right triangle?